Everyone, and good afternoon to all. This is the fifth day of a 75 days lead coding challenge, and here is the problem, which name is validate binary tree nodes. So before going into the problem statement, please make sure that you have like and subscribe to this video. So let's read the problem. The problem statement is saying that we have given a n binary tree nodes numbered from 0 to n minus 1, where node of I has two children, left child and right child. Return true if and only if all the given nodes from exactly one binary tree. So let's read the problem by yourself and think about this. Then I will describe the approach for this. So basically in this problem, the problem is saying that we have given a n number of binary tree, and we have given left child and right child. So what is the condition for valid binary tree? You can see in this problem statement. I am explaining you. So the condition of valid binary tree is there should be no repeated, means there should be no cycle. In binary tree there should be no cycle and no node should be repeated. It means if 1 is coming only one time, then 2 is coming only one time, means no node should be repeated and all nodes should be there. Means if a left child is this one, then all nodes should be there. So if left child is -1, so it means it is pointing to the null pointer, so no need to worry about this. So let's see this. Yeah. So there, here is the condition for valid binary tree. We can see there should be no cycle. First condition is there should be no cycle. If cycle is present there, then it is not a valid binary tree. And second condition is no node should be repeated. It means if one node is repeating, then we can say that this is not a valid binary tree basically, or all nodes should be there. It means if left child is 1 minus 1, 3 minus 1, so no need to worry about the -1. So 1 and 3 is present, and 2 and 2 only 2 2 is present. So let's see the example. If n equals to 4, then yeah, in C condition all nodes should be there. It means n equals to 3, then n equals to 4, then the count will be 4. If count equals to 3, I am starting from 1. If count equals to 3, then we can say it is not a valid binary tree. So let's see the example. We have given a left child and right child. So for 0th index, we will take 0, and parent of 0 equals to -1, because no parent is there for 0. So we will take this as -1. For 0th node, left child is 1 and right child is 2. So we are taking left child is 1, right child is 2. For 1th index, -1 left child or right child be -1. So no need to take this. I am taking just because you can understand, but in further I will remove that. Let's see the index 2. In index 2, their left child is 3 and right child is -1. So left child is 3 and right child is -1. And for index 4, left and right both are -1, so no need to take this. I am removing this -1 here. So this is my final tree. We can see in this tree there is no cycle present, and the number of nodes is 4, which is n equals to 4. So it's a valid binary tree, we can say. So we will mark as true. So we have to check these three conditions. If cycle is present, then it will be not a valid binary tree. If ancestor we have to check, because if ancestor of, it means if let's take the example, if a parent of 2 equals to -1, sorry, parent of 2 equals to 1 and parent of 3 equals to 1, it means yeah, it can be there, but parent of 2 equals to 1 and parent of 3 equals to also 1, then it will be not a valid binary tree. So we have to check the ancestor also, and we have to check number of nodes also. So let's go on the coding part. Let's discuss about, just think about this and how we can approach this. I explained the approach. Let's think about the code by yourself, because if you do not understand this, if you do not try to code yourself, then you will learn nothing, I can say. If you want to do code, if you want to be a pro coder, then you have to do the code by yourself. So let's think about by yourself, and I am going to write the code now. So let's off this quick time player. Now I will explain you about this. Yeah, let's write the code. So firstly I will float on top. Yes. So firstly I will take int count equals to n minus 1. I am starting from n minus 1. It means I am start, for example 1, I am starting from 3. Then it will, if it will go to 0, then it's true, otherwise false. Yeah, you can see this example also. Here is the cycle is present, then we will mark it as a false. Yeah, so it is done. So we have taken the int count equals to n minus 1. Let's create a int visited. We will check if it is visited or not. Visited, mark it size is n and mark it as 0. Okay, done. Let's take vector int not visited. Visited we have done. We'll take vector int parent of initially parent of 0 equals to minus 1, so initialize is minus 1. So let's write the code for int I equals to 0 to I less than n, then I plus plus, and we will traverse from left child and right child will be the same. Then only we have to think about the left child. So if left child क्या ही लिख दिया. If left child of I equals to minus 1, if left child is minus 1, then no need to worry about this. So directly we can say continue. Done. Now if we will check if visited of left child, actually copy this directly. ये सी क्यों नहीं प्रिंट हुआ इसमें, अब हो गया. लेफ्ट चाइल्ड ऑफ आई equals to 1. It means it is visited, then return false. This is done. Then now what we will do, we'll check int temp. We'll create int temp equals to parent of I. Okay, and we'll apply a loop, and we'll check if temp up to the temp is not equals to 0. Actually temp is not equals to minus 1 also, because the parent of 0 equals to minus 1. हम तब तक चेक करेंगे तब तक का पेरेंट ऑफ 0 इक्वल टू -1 नहीं होता था. और वील चेक if the number, it means let's write this, if temp equals to left child of I, इट मीन्स वो नंबर रिपीट कर रहा है, मीन्स उसका चाइल्ड, मैंने बोला ना एंसेस्टर रिपीट कर रहा है, तो वी विल डायरेक्टली रिटर्न इट एज फॉल्स. दिस इज डन एंड विल से temp equals to parent of temp. Yeah, this is done. So we have done this, the cycle part or the ancestor part. You have to make this diagram like this so that you can understand better this line. So we have done this part also. So after this we have to do one thing. If the parent of left child of I, parent of left child of I equals to I, and visited of left child of I equals to true, means 1. This we have done, and count minus, and now we will copy this and paste this like this, and now this will be for right child. Let's copy this, because left and right will be the same, approach is same. So let's do this fast. Yes, we have completed this part also. So now we will check if count not equals to 0. अगर count 0 नहीं होता तो we will mark it as false, otherwise it is true. This is done. Let's run this code. It is working perfect. Let's submit this. Yeah, it is working perfectly, taking 28 millisecond and beats 93.31% of C++ user. It is a better solution for this. So let's discuss about the time and space complexity for this solution. So we can see that we are taking the space, vector space, and here is also the vector space. So we can say the space complexity will be big O of n, and the time complexity will be big O of n plus n into n by 2, because it will maximum it will run in n by 2 times, so n into n by 2. So it is a time and space complexity. So if you find this solution helpful, then please like, share and subscribe to this channel. And if you know another approaches for this solution, for this question also, so please comment out. I'll see that approach and I will do that also, and I will appreciate you in next video. So till now we have completed our 5 days. So let's buy and do the code by yourself. Okay, bye.